Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.2, Problem 37. This is Section 2.2, Problem 37. It says, examine the following matrices and determine for each one if they have one solution, no solution, or infinitely many solutions. Check the appropriate box below each matrix. So what we have is 4 different matrices. Each one's been solved pretty much as far as it can go. You have the ones and zeros, and what's going to determine which one of those 3 cases you have is the bottom row. The bottom row is going to tell you. So look at the first one. You've got your 1 zeros. If you look at the bottom row, this one has one solution. And specifically, that one solution is x equals 6, y equals 3, z equals 4. So of my options, one solution, no solution, infinitely many solution, the one solution is the correct box to choose. Now, on to the next matrix. It's almost exactly the same as the first matrix. What's changed? Just the bottom row, these 2 positions here. The top row is the same, the middle row is the same. Bottom row has changed. The bottom row is now all zeros. So the way that changes it is that all zero row is giving you infinitely many solutions. So of my options, one solution, no solution, infinitely many solutions, you check the bottom box. And again, why? Well, that bottom row is representing the equation 0x plus 0y plus 0z equals 0. Well, there's an infinite combinations of x, y, and z that are going to make that equation true. Right? I can put in all kinds of stuff for x, y, and z. When I get multiplied by the 0 in front, I get a true equation, 0 equals 0. There's a lot of examples that will make it work. The next matrix, again, notice, almost the same. The top row is still 1, 0, 0, 6. The middle row, 0, 1, 0, 3. The bottom row has changed a little bit. What's different? That bottom rightmost corner wasn't 0 in the previous example. Now it's just a 4. So 0, 0, 0, 4. That's something a little bit different. So which situation is this? This could be one solution, could be no solution, could be infinitely many solutions. Which one is it? If you're not sure, look at that bottom row and ask yourself, what equation is that bottom row representing? Well, what equation is it representing? It is representing the equation 0x plus 0y plus 0z equals 4. Can that ever be true for any value of x, y, and z? No. No matter what you put in for x, y, and z, because they're getting multiplied times 0, you're going to get the equation 0 equals 4. That's just not true. 0 does not equal 4. There are no values of x, y, and z that are ever going to make 0 equal to 4. So of my options, one solution, no solution, infinitely many solutions, the correct choice would be no solution. There is no solution for that matrix. The next one looks almost the same. Again, the top row is the same, 1, 0, 0, 6. The second row is the same, 0, 1, 0, 3. The bottom row changed a little bit, 0, 0, 4, 0. The 4 and the 0 interchange positions. Does that change the answer? It does change the answer. Well, again, if you're not sure, ask yourself, what equation does this represent? 0x plus 0y plus 4z equals 0. Could that happen? Actually, it could. What value of z do I need to make this 0 equals 0? Well, if z is 0, it would work. Right? The top row is saying that x is equal to 6. The second row is saying that y is equal to 3. And actually, the bottom row is saying that z is equal to 0. So this one has one solution, and that is the one solution. X is 6, y is 3, z is 0. This one technically is not really finished to the end. Right? This one we could multiply through by 1 over 4. You get 4 over 4 here, and it reduces to 1, and then it would be more clear. So this is a tricky one, the last one. So of my options, one solution, no solution, infinitely many solutions, the correct choice is one solution. This one solution, x is 6, y is 3, z is 0.